What if I told you that the most powerful telescope ever built can actually look billions of years into the past? I know it sounds completely impossible, right? Like something straight out of a sci-fi movie. But it's actually happening right now, way above our heads, out in the freezing, dark vacuum of space.
So, how exactly can a telescope become a time machine? I mean, just think about that for a second. The answer to that question happens to be one of the greatest scientific discoveries in all of human history. Today, in this explainer, we're going to dive into the incredible true story of the James Webb Space Telescope, how the heck it actually works, and what it's already revealing to us.
Section 1. The Ultimate Time Machine and Humanity's Biggest Questions. For decades, scientists dreamed of building a telescope that was far more powerful than the legendary Hubble. They knew they needed that immense, next-level power to answer humanity's absolute biggest mysteries. Questions like, how did the first galaxies actually form? Are we alone in the universe? And, what did the universe even look like shortly after the Big Bang? We're talking about the fundamental questions regarding the origins of absolutely everything.
Which brings us to Section 2, Engineering the Impossible and Building the Web.
Building this thing wasn't something just one group could pull off. No way! It took a massive international collaboration between NASA, the European Space Agency, and the Canadian Space Agency. And after years of meticulous, nerve-wracking testing, it finally launched on December 25, 2021. Talk about the ultimate Christmas present for humanity. But getting off the launch pad was really just the beginning of a 1.5 million kilometer journey to its final destination, a spot called Lagrange Point 2.
To really grasp the ambition here, you kind of have to look at the contrast. Hubble, as amazing as it is, orbits relatively close to Earth. But James Webb? It traveled out nearly 1.5 million kilometers away to L2, going way, way beyond the reach of any older telescopes. 1.5 million kilometers? Why park it so incredibly far away? Well, out there at L2, the telescope can observe the deep universe while staying entirely shielded from the blinding heat and light of the sun, the Earth, and the moon. It needs absolute pitch-black cold to do its job.
And once it finally made that epic journey, it had to pull off this triumphant engineering feat out in the harshness of space. Step 1. Reach L2. Step 2. Its giant gold-coated mirror, which is made up of 18 hexagonal segments, had to carefully unfold in space, just like a giant billion-dollar puzzle. And finally, Step 3. Every single one of those segments has to work together flawlessly to collect extremely faint light from incredibly distant objects.
All right, Section 3, the infrared advantage, or seeing the unseen.
Now, this is where we get into the real magic of this machine. It mainly observes the universe in infrared light. But you might be wondering, why is observing in infrared so important? Well, this sets up the brilliant physics behind how it actually looks back in time. It all comes down to this wild concept called infrared shift. See, because the universe has been expanding for billions of years, the light from the very earliest galaxies has literally been stretched out as it traveled toward us. It's kind of like pulling a rubber band. Because of that stretching, much of that ancient light has shifted completely out of the visible spectrum right into the infrared range.
And that is a total game changer. It means James Webb, with its specialized infrared vision, can detect objects that older telescopes could barely see, or just couldn't see at all. It literally allows us to spot ancient wonders that were completely invisible to us before this telescope was turned on.
Moving to Section 4, Rewriting the Cosmos and Those Incredible First Observations.
Let me tell you, the wait was completely worth it. In its very first observations, the telescope delivered a single image containing thousands of distant galaxies. Thousands! And here's a number that will just blow your mind. Scientists were absolutely amazed to find that some of those galaxies formed only a few 100 million years after the Big Bang. We are looking directly into the infancy of the universe.
But Webb isn't just looking at ancient galaxies. It's doing something else that's just as incredible. It's actually analyzing tiny changes in light to study the atmospheres of exoplanets. Those are planets orbiting entirely different distant stars way out in our galaxy.
Looking at those minute changes in the light, researchers can precisely identify specific gases in those atmospheres. We're talking about things like water vapor, carbon dioxide, and methane. Finding these specific gases helps scientists figure out exactly how these planets form and, crucially, whether some of these distant worlds could actually have conditions suitable for life.
Oh, and it has also captured these breathtaking images of star-forming regions. These spectacular stellar nurseries are where brand new stars are actively being born deep inside enormous glowing clouds of gas and dust. It's almost hard to wrap your head around. Every single new observation we get from Webb teaches us something about the universe that we just didn't know yesterday.
And finally, Section 5, our place in space, moving beyond just the data.
Now, while the images are visually stunning and the exoplanet research is absolutely thrilling, it's important to clarify the bigger picture here. James Webb isn't just up there hunting for aliens. Its main mission is to help scientists definitively understand the origins of galaxies, stars, planets, and the entire history of our universe. What it is finding today is literally going to shape astronomy for decades to come.
Ultimately, what you should take away from all of this is what this achievement really represents for us. The James Webb Space Telescope reminds us that curiosity is the ultimate engine of human progress. That burning desire to know what is out there in the dark, that's what pushes us forward.
Take a moment to just think about this. Every time we look deeper into space, we also learn more about ourselves and our place in the cosmos. The telescope isn't just a lens looking outward, it's a mirror reflecting our own relentless drive to understand exactly where we come from. And I'll leave you with this powerful thought, because sometimes the greatest journey isn't across oceans, it's across the universe. If Webb is already rewriting textbooks in its first few years, what impossible things is it going to show us tomorrow? If you enjoy educational documentaries, science, space, and amazing true stories, be sure to subscribe for more explainers that explore the wonders of our universe. Keep looking up, and I'll catch you next time.